Welcome to the video lecture series on digital signal processing. We were already discussing about the various problems using Z transform. Uh, Already we have seen four problems. Before going to the next set of problems, I want to explain you about the certain sequence that is shown here. Minus 1 by 2 the power n, u of minus n minus 1 minus 1 by 4 power n u of minus n minus 1. Though this seems to be an expression, how many of you know have the visualization of how the sequence will be? Similarly, for the next sequence, 1 by 4 power n u of n minus 1 by 2 the whole power n u of minus, how the signal will be and where the signal will be. How many of you have the visualization to show that this video is taken? And similarly, sine omega naught n u of n, this also needs clarity. So, for giving you an idea about how the sequence will be, I have taken the MATLAB code for this, and you can see this code. This first code is about 1 by 4 power n u of n, which means that 0.25 power n u of n. So at n is equal to 0, its value is 1. So it is 1. What will be the value at n is equal to 1? It will be 0.25. See, at n is equal to 1, it is 0.25. What will be the value at n is equal to 2.25 the whole square, which is nothing but you'll get at this point. Similarly, 0.25 the whole cube, 0.25 the whole power 4. So similarly, the sequence is represented as 1 by 4 power n u of n in the expression. The second point in this is minus 1 by 2 the whole power n u of minus n minus 1. To know this, the sequence, can you see it? Again, it starts from 0 and the sequence is in the negative axis. This is 0, this is minus 2, minus 4. The sequence lies in the negative axis. This sequence lies like this in the positive axis. This sequence lies in the negative axis like this. See, at this point, n value is minus 9, the value is minus 512. So what you can understand, now you're going to do some arithmetic operation on these two sequence and you're going to see what is the final value. So final sequence will be like this. This can be, but our main motive is to find the Z transform of this particular sequence. Now, can you get an idea how combining these two signals will be there, and how the sequence of these two signals will be there? Similarly, if you take minus 1 by 2 the whole power n u of minus n minus 1 and this, what is the difference between these two? This was in positive region, but if you go to these two signals, it will be in negative region. Just go to that particular example. You can see on running it, you can see both the sequence are in negative sequence. Both the signals are in negative region. So there is no positive value. What I'm doing is I'm going to make it as 0 and make it as 20 and run. Let me see what is going to happen. See, it is starting. Now you can see the sequence clearly, right? 0 in the negative axis. Final resultant is also at the negative axis. So on arithmetic operation, that is by combining these two signals, we will get the final sequence like this again in the negative axis. The next one is sine omega naught n u of n. So this is nothing but from the expression itself, we can understand that the sequence will be sinusoidal in nature. Can you understand this? Yes, it will be sinusoidal in nature. So let me go to that particular sine signal also. What I have given is 24 steps. Because I have divided the single cycle into 8 discrete samples. So 1624, I will get 3 cycle, one upper cycle, one negative cycle and another one positive cycle. So now I am going to run this. So I'll get a discrete sequence like this. If so, what it means is we have to find the Z transform for this particular sequence. Now going on to the next one. Can you see R power n sine omega naught n? This is something different. Sin omega naught n is multiplied by r power n. Can anyone imagine how a sequence will be? Let us see how a sequence will be available. See, the same sine signal which is divided by 8, it is multiplied by r power n. R value what I have taken is 0.8. It is less than 1. What will happen to this sequence? Can anyone imagine what will happen to this sequence when, let us see how it is going to get. See, only first half of the cycle will be available, next half it is decaying because R value is zero point 0.8. Can you see the difference? Can you analyze the sequence? Let me make the R value as 1. You will get a same sign signal as previous example. You got it right? If I make R value as 2, what will happen? Anyone can you imagine? See. Can you see the difference? Can you see the value? It is not 0. It is around 2.5 into 10 power 11. So it is continuously increasing. The sinusoidal will be continuously increasing. Let me take it as 1.2. Can you see how the value is changing? If it is 1.1. Can you understand how the sequence gets modified when you do arithmetic operations like multiplication, addition of two signals, or modification of two signals? All these things you have already seen in the previous signals and systems itself, but still. To recollect it, I told you in this video lecture. Thank you for patient listening.